Hello and welcome back. Today we have this small excavator machine. We are going to make this machine work. Moving forward, backward, rotating, controlling hydraulic parts. We are going to use setup from previous tutorial. What is specific for this vehicle is obvious. There are no wheels, so we are not going to use wheel colliders. So let's see how to make this. This is our scene from previous video. Let's disable script component from our truck. That will just stop truck moving, and import our model. Again, you can download this FBX from my itch.io page, link is in description. Drag FBX to the scene. Same as before, drag color palette to the project and we will get color. We have this action input from before and also the script. What will I do? I will just duplicate that script and we will do changes on that one later. Let's check the script. It is important to rename class. And let's go back to our scene for now. Let's see our object. So main object excavator has child object body. From that one we can see nested all articulated parts of the excavator. Boom, stick and the bucket. Add some physics, start with rigid body as usual. Adjust damping to make movement more realistic. Add box colliders. Add script. And player input. Set up this component exactly as before. Go back to our script. It's not a truck anymore, it's machine. There are no wheels, so we delete all these references to wheel colliders and wheel meshes. We need slightly different variables. Moving force, turning force, and maximum linear and angular speed. We will make this vehicle move by adding force to the rigid body. So when the force stops, friction and mass will stop rigid body. That means that we don't need this boolean is braking. We also don't need procedure handling input for braking. Same way, we will steer this machine by adding torque to different directions. So that means we don't need all these procedures. We don't have wheel colliders, delete this. So no steering, no braking, no updating wheel meshes, no wheel colliders. Now let's make simple movement forward and backwards. I will make some variables now. They will help me even later for turning. I will explain later what is the idea with these variables. So let's see what is the idea. From user input we have this throttle and steering variables. Throttle is -1 when we go backwards, 0 when we stop, and 1 when we go forward. Similar for the steering, -1 for the left, +1 for the right, 0 for straight. So that means when we want to go straight, left track and right track variables will have the same value, 1 or -1, depending on direction. When we want to turn, one of them is going to be 2 and one of them is going to be 0. Again, depending on direction of turning. Now this new variable moving is for going forward and backwards, will be 1 or -1. Similar, the variable turning will be -2, 0 or 2, depending on direction of turning. Let's add force. First, limit the speed of this rigid body. I always forget magnitude. Add force. Forward direction times moving variable times move force that is already defined. Let's see if that works. Drag our game object to respective field in the script. Do the same for speedometer from previous video. Connect action input with action. Same way as before. W and S are controls that we set up before. Okay, so that works. Now let's try to add steering. First, limit turning speed. And then add torque. Up vector times our variable turning times our turn force that we already defined. Let's check this now. A for left, D for right, and we are moving. We can go straight and rotating at the same time. If we want to adjust steering angle, we need to change variable angular speed. Lower angular speed, bigger circle we are making. Let's play with hydraulic parts now. Check the car input controller that we made before. We are not going to use brake, so we can delete that one. And create action for rotating body of this excavator. Action type value, control type axis. Delete original binding and add ours. Add positive negative binding. And choose control that we are going to use for rotating. I will go with X and Z. One will rotate body clockwise and another one counterclockwise. Again, important to save asset. Well, let's make another procedure in our script for hydraulics. And call that procedure every frame after applying torque. Make reference to the body part of our excavator. I will need a variable for handling user input for rotating. I will name it body F as F for float. Go back to our new procedure. So we will do something only in case our variable is different than 0. Actually, body F variable can be -1, 0, and 1, depending on user input. So we will simply just rotate this body for half of degree. Clockwise or counterclockwise, depending on value of this variable. I skipped one important step to handle user input. I will make one procedure to handle user input to control articulated parts, boom, stick and bucket. And one procedure to handle input for rotating body. So here we will store user input to body F variable. Now we need to add that procedure to our player input component of our machine, the same way as before. And let's try. Something is wrong. I didn't make a reference to the body part of this excavator. Try again. Now by pressing X or Z, body is rotating. Let's add control to our articulated parts. Open our controller again. Add new action. This time type will be vector3. That's because I want to handle 6 variables, 2 for each part of hydraulics. Delete original binding and add ours. Composite. So here we have 6 directions: up, down, left, right, forward and backward. Choose your controls. I will go with R and F for stick, T and G for boom, and Y and H for bucket. Roll here, save asset important. Add this control to player input as before. And do the coding. This local variable will handle user input. Now we need 3 more variables and 3 more references for boom, stick and bucket. Go back to our procedure. Component Y of our vector3 will be in charge for boom, component X will be in charge for stick, and component Z will be in charge for bucket. Again, all of those can be -1, 0 and 1 depending on user input. Now we need to do something with that input. Again, we will do something only when that variable is not 0. We need more variables. I will make variables that will store current angle of all articulated parts. So we adjust angle by half of degree in direction depending of our variable. And then we change local rotation of specific part to that angle. Using Euler quaternion. We are actually rotating only by axis x. Y and Z will stay 0. And we do the same for stick and bucket. Let's see what we got. Don't forget references this time. Something is wrong. Our parser not moving properly. Okay, I see the mistake. So I was actually assigning half of degree to angle variable, not adjusting by half a degree. Let's see now. And it works. What's wrong with this? We didn't set up any limits. I will show how to set limits for one part, and then you can try by yourself for the others. New variables. Upper limit and lower limit. I already tested this before, so I know exactly which limit I need to put. And it's actually very simple. Use metf clamp function. What is this function doing? It is checking if first parameter is between the second and third parameter. So if the value of first parameter is lower of the limit or higher of the other limit, the result of this function will be exactly that limit. Now we try again. Not good. Let's see what is wrong. Limits looks good. So I swapped upper and lower limit. Let me know if you would like to hear further explanation for this mistake. It looks good. You can try by yourself for other parts. Let me know in the comments if you managed to do it. Let's see what we got in the end. Adjust position of the camera to our excavator. And play. And that will be all for today. Thanks for watching.